For decades, corporate finance has viewed physical asset monitoring, inspecting roofs, bridges, and infrastructure, as a defensive operational expense, money spent to keep the lights on and the rain out. CFOs, CPAs, and property managers traditionally treat these physical inspections as an unavoidable sunk cost. It is a line item that drains budgets without generating direct financial return. The deployment of high-fidelity uncrewed aerial systems, or UAS, breaks that cycle. UAS refers to commercial-grade drones equipped with advanced sensors, like thermal cameras and precision GPS. The enterprise value of this technology stems from the financial engineering the data enables, rather than the mechanical act of flight. Structured aerial asset intelligence facilitates precise tax timing, accelerated depreciation schedules, and a documented reduction in physical liability exposure. When integrated into core financial reporting, these data captures provide a foundation for measurable operational returns. Drone data alters the core nature of physical maintenance. It takes a reactive, unpredictable expense and turns it into predictable financial leverage. Traditional analog inspections require human personnel to access elevated, dangerous environments. This exposes organizations to high-frequency, high-severity physical hazards. The statistical liability is significant. Falls from ladders generate average lost time claims starting at $68,000 in direct medical and wage replacement costs per incident. To avoid ladder falls on large infrastructure, agencies rely on heavy inspection machinery, like snooper trucks. These carry a massive capital expenditure, or CapEx, costing upwards of $800,000 to purchase and averaging $40,000 to deploy for a single bridge inspection. Replacing these methods with drones eliminates the organization's exposure to catastrophic workers' compensation and negligence claims by keeping human workers safely on the ground. Beyond physical safety, digital data optimizes operational timing. High-fidelity sensors catch structural anomalies, like moisture intrusion or early-stage oxidation, years before a catastrophic failure occurs. Identifying these micro-level defects early prevents emergency facility shutdowns and avoids the premium pricing associated with rush-order repair parts. By removing physical risk and catching degradation early, organizations shift unpredictable, high-cost emergency capital expenditures into controlled, low-cost operational expenditures. The operational savings are clear, but the primary executive leverage lies in controlling the timing of tax deductions. Under general accounting principles, prepaid services that extend substantially into a new tax year must typically be capitalized. They cannot be deducted immediately. This diagram illustrates a strategic exception for cash-basis taxpayers, the IRS 12-month rule, found in Treasury Regulations Section 1.263A-4F. Under this rule, businesses can prepay for 12 months of drone inspection retainers at year-end. This allows the organization to deduct the payment immediately, lowering taxable income in the current year while securing maintenance services for the next 12 months. Accrual-basis taxpayers face a different hurdle. They are bound by the economic performance test, which requires services to be rendered before a deduction can be claimed. However, the ratable service safe harbor, outlined in Revenue Procedure 2015-39, allows accrual-basis corporations to achieve similar tax timing flexibility. They structure the inspection contract as a regular, recurring service, rather than a single lump sum. Formalizing an annual drone inspection contract converts routine facility maintenance into a predictable strategy for reducing year-end taxable income. The value of corporate asset data is dictated by its objective veracity and its ability to comply with IRS documentation requirements during an audit. Consider cost segregation. This is an IRS-approved tax strategy that reclassifies components of a commercial building from a 39-year depreciation schedule down to a shorter 5, 7, or 15-year schedule. Traditional manual estimates often fail under IRS scrutiny because they lack definitive proof of a component's exact placement and function. This visual model demonstrates how drones capture the exact geometric proof CPAs need. By utilizing RTK precision, a highly accurate satellite navigation technique, drones generate orthomosaics and 3D point clouds that document and defend these reclassifications. This precise geometric sorting maximizes the current bonus depreciation allowances for the organization, accelerating capital recovery. The Tangible Property Regulations, or TPR, present another compliance hurdle. These rules govern the tax difference between an immediate repair expense and a capitalized improvement. Defending an immediate repair deduction requires proving the asset's pre-existing condition. Date-stamped geo-referenced drone imagery serves as an indisputable before baseline. High-fidelity drone data acts as a legal and accounting shield. It replaces subjective human estimates with definitive, audit-ready substantiation. This data leverage scales well beyond commercial real estate, impacting agriculture and infrastructure management. Manual field scouting sets a slow baseline that precision agriculture disrupts. In the agricultural sector, IRS Section 179 allows operators to immediately write off the entire UAS capital stack, including hardware, sensors, and processing software, in the year of purchase. This diagram illustrates how multispectral drone sensors calculate Normalized Difference Vegetation Index, or NDVI, data. NDVI quantifies plant health, allowing farmers to create variable rate application maps that target chemical inputs only where needed, reducing overall usage by over 45%. These geo-referenced maps also serve as the auditable proof required for state environmental mandates, like Ohio's H2 Ohio initiative, legally documenting right rate, right place nutrient application. In emergency scenarios, the speed of drone data acquisition compresses the timeline for post-disaster financial recovery. Immediate post-storm aerial surveys provide the exact date and damage estimations required by local auditors to secure property tax relief, like Ohio's DTE Form 26. Comprehensive pre-loss and post-loss drone records accelerate the insurance claim cycle time by up to 60%, enabling the release of federal and state relief funds in a shorter timeframe. Whether proving environmental stewardship or accelerating a disaster claim, digitized physical data is a fast mechanism to secure regulatory compliance and insurance capital. Analog property inspections provide a level of subjectivity that modern asset management can no longer support. This diagram illustrates the interconnected power of asset intelligence. When an organization adopts routine aerial data, it feeds multiple corporate divisions simultaneously from a single source of truth. The data flows to maintenance to help predict failures and lower emergency capital expenditures, and to legal to mitigate negligence liability. Simultaneously, the exact same data flows to accounting to optimize property apportionment factors, and to insurance carriers to justify property and casualty premium discounts. Generating this objective digital baseline ensures that the fiduciary duty of the board and the executive team is provably and legally met. Failing to digitize these processes leaves the organization exposed to IRS audit penalties, inflated insurance premiums, and documented physical liabilities. Routine aerial asset management aligns the requirements of physical maintenance with the goals of corporate finance, establishing a documented baseline for safety, tax efficiency, and predictable operational results.